All right, so for this example, I'm going to be looking at some data about used Toyota Corollas that are for sale out of this Ithaca journal. And so again, hopefully you've had a chance to type in these different pieces of information into your calculator, into a new document. If you haven't, go ahead and pause now and make sure you type it in before we look at the rest of the video. So I want to see if there is a relationship between the age of a used car and the price, and to see if there is, what that relationship might be. So I have the information here, and for the problem, it wants us to first create a scatter plot that describes this association. So I'm going to create a scatter plot. So doc, insert, data and statistics, and here's where you want to ask yourself the question, which one is explaining the other? So which variable do you think is explaining the other variable? So which one is your explanatory? So for this, we have the age, or how old a car is, and the price of the car. And so I'm going to say that the age of a car explains the price. So I'm going to make age the explanatory variable, the x-axis, and the price I'm going to make the y-axis. All right, and so you can see it looks like we have a relationship here. And what I'm going to do when it says, do you think it's appropriate? Basically, I want to first think about form, direction, and strength. And then when I think about form, if I think that this is linear, then I feel comfortable proceeding with running a linear regression model. So that's kind of the first check. We know they're both quantitative variables. We have age in years, price in dollars. So we're good there. We're okay to make the scatter plot. Now the question is, can we keep going and actually run a linear regression model? So I'm going to say there is it looks like this is negative, because it's going from the top left to the bottom right. So negative, linear, I'd say strong, because there's not as much difference between the points here, not much scatter. So there is a negative, linear, strong association between the age and price of a Toyota Corolla. All right, so that means it's appropriate to run the linear regression model. So I'm going to go ahead and do that. Doc, insert a calculator page. And this is where I'm going to do the linear regression A plus BX. So statistics, stat calculations, and then number 4, A plus BX. So my explanatory or X variable is age. My response variable or Y value is price. Again, I'm looking at it, saving it to F1 for future reference, and hit OK. Now, a couple of things that I would point out first, or look at first. I see R is negative 0.972. Again, that's really close to -1, so that is a strong linear relationship between these two variables. All right? Now let's look at A and B. So A again is the y-intercept and B is the slope. So if we look at our paper, we've already answered both of these. All right, let's go ahead and find where it says to write down the model. There we go. So letter F says to find the equation of the regression line. So this is where I'm going to write down my y value, which is price. And because this is predicted, I'm going to put price hat equals, and I have a y-intercept of $14,285.90. $14,285.90 minus, and you can always write plus and then negative for your slope, but I go ahead and just write minus because I know I have a negative slope here. So minus 959.05, 959.05, 959.05 times the age, or how old our car is. Make sure that's right, 959.05. Great. All right, so there is the equation of the regression line. Now, before I go any further, I always want to make sure that it's still appropriate to use a linear regression model. Now, we already made sure that the scatter plot showed a linear relationship, so that was the first check. But after that, you want to make sure that you check the residuals plot. Now, you have to wait until you actually run the regression model. So like this work here where it says linear regression of these two variables. You must do this first, because if you don't do this, then the computer hasn't calculated the residuals yet. So now that you've done it, it has gone and taken every single piece of data, so all of these pieces of data here, and it has found a residual. Remember, that's the observed price, so all these prices that are here, all the prices in this column, minus their predicted prices based on how old the car is, and that creates the residual. All right, so I want to check that by inserting, so doc insert, a new data and statistics page. Keep in mind you want to use the same explanatory variable, which is the age, but instead of using price, we're now going to use stat.residual. So again, if you don't run the regression, none of these stat, dot, and whatever, they don't show up. So you'll know that you need to run the regression first. All right. Now again, I'm looking for no pattern here. So when I look at this, you want to see, is there a pattern? It doesn't really look like there's a pattern. Again, if there was a pattern, like a curve, or as we'll talk about, a fan shape, where they start off really clustered tight together and then they kind of increase their distance from each other. If there was some kind of pattern, then we would say that the linear model is not appropriate and we would stop using the model we just wrote down. All right, that gets into chapter 9 and 10 when we look at re-expressing. So as I said a long time ago, we're going to end up using functions that you've learned in Algebra 2 and in pre-calculus to look at how we can re-express this data to manipulate it and create a linear relationship. So for our purposes, though, I think that it's still appropriate. It doesn't look like this residuals plot has a pattern. So I'm going to keep going, which means that I'm going to answer those questions underneath the equation for the regression line. So basically talk about what does the slope mean and what does the y-intercept mean. So for the slope, that is the negative 959.05. And so basically what this means, that for every year that your Toyota Corolla ages, so every year that your Corolla gets older, that you can expect the price of you selling that car to decrease by $959.05. So basically, every year you own the Corolla, you can, if you want to sell it, you're going to need to take off about $1,000. Now again, that is what the model is predicting will happen. That's not necessarily true, right? Because we'll talk about later why that's not only the only factor, but what the model is saying here, what the slope is saying, is that every year your Toyota Corolla ages, you can expect the price to drop by $959.05. All right? Notice I'm saying price drop because it is a negative. All right? So just keep that in mind for the slope. Now for the y-intercept. The y-intercept is $14,285.90. Now, remember from your algebra days, the y-intercept means that the x value, in this case the age, is 0. So if we think about the age of a car being 0, basically we're saying that is a brand new Toyota Corolla. So the Toyota Corolla here, we can expect, if we buy a brand new Toyota Corolla, to pay about $14,285.90. All right, so that's what the model is predicting. I don't know what a brand new Toyota Corolla costs, but based on this data, that's what we expect to pay. All right, so hopefully you guys are feeling confident about this. We've been talking about this for a while, and again, even if you're still worried, we're going to talk about it for many more weeks. All right, so then let's look at answering some more questions, going out of order here. We already answered A and B, so let's look at C, D, and E. Now, it says the computer software says that R squared is 94.4%, but you should see we have that data. We found it. If you go back to where you have your linear regression model, we've already used A, we've already used B. We've mentioned how R is very strong in a negative direction. And then the R squared. Now again, this is one of those concepts that takes some time to understand, but R squared is basically, we're looking at how much of your response variable is explained by your explanatory. All right, so a lot of times statisticians like to think of R squared as kind of a check to see how good your model is, and I know you can't see me, but I just did air quotes for good. The idea being that we know that models are always wrong, all right, but sometimes R squared is a good check to see, is it good in the sense that it's explaining a lot of the change. So what I would write for letter C would be something like this. 94.4% of the change in the price of a used Toyota Corolla can be explained by the age of it, so how old it is. So I'll repeat that again. 94.4% of the change in the price of a Toyota Corolla can be explained by how old it is. All right, so that's a lot. That's close to 100%. So, but there still leaves room for a little bit over 5% of that price is explained by other things. So when I'm just thinking about what other things could cause the price of a used car, I'm thinking, my favorite commercial, show me the Carfax. A lot of times you have accidents or flooding that could cause damage to the car, and so that's something that could decrease the value of it. So really I'm just thinking about the condition of the car. What kind of condition is it in? All right. Okay, so that answers C. We also answered D. I guess C, I'm sorry, the correlation, it says what is the correlation? So technically C would be R equals negative points, I know it was close to negative 1.972. So I apologize for that. 972. So that is R. So what I really just got done saying was more like D, where it says explain the meaning of R squared. So that, what you just wrote down for C, is actually letter D. Okay. We already talked about E, why this model isn't explaining 100% of it. We talked about the condition of the car, the accident report, things like that. I forgot, maybe the mileage of it, right? If you have a 2-year-old car, but you've already put 75,000 miles on it, as opposed to a 2-year-old car that only has 10,000 miles. So that's one thing as well. I forgot about that. All right. So I feel good about those questions. We've already answered F, G, and H. Let's see what else they want us to look at. Okay. If you want to sell a 7-year-old Corolla, what price seems appropriate? So we're going to use this model, and you're more than welcome to type in, this whole thing times 7 for the age. But again, the whole point of using the calculator is that we don't need to do that. We just type in F1 of 7. And that should give us what we would expect to price this used car at. So $7,572.63. So $7,752.63. Make sure I wrote that right. I probably didn't. Let's check. I messed the numbers up. 7572. 7572. All right. Okay. So again, I'm not saying that that's the price that you should list your used car at, but the model is saying if you want to get a fair price based on all the other Corollas that have been sold in the past, this is the price that you should use. All right? Now, question J. Would you rather buy a used Corolla with a positive or a negative residual? Now, when I answer these, I always just make up stuff. All right? So first thing you need to know is how do you find a residual? Well, a residual is observed minus predicted. All right? So I just think, okay, how much did I actually pay for my used Corolla? Let's say I paid $5,000. All right? The model says that I should have paid $6,000. So if I calculate that residual, that would be a negative residual. So I ask myself, am I getting a deal here? Well, the model predicts that I should have paid $6,000, but I only paid $5,000. So I basically underpaid, got a deal by about $1,000. So a negative residual is actually a benefit to the consumer, the person that's actually buying the car. So if it was flipped and you paid $6,000, but the model said you should have paid $5,000, then you actually overpaid. So a positive residual would not be in your best interest. So again, you would rather buy a used Corolla with a negative residual. All right, letter K. You see a for sale sign on a 10-year-old Corolla stating the asking price is $3,500. What is the residual? Okay, so again, so I'm going to give you guys a little bit more room to see this. We should have residual equals observed minus expected. Sorry, I'm going to use the same language, predicted. But expected is the same. Same thing. All right. So they're saying the asking price is $3,500. So that is the observed price. All right. That's what they have on the sign. All right. So we want to find out, well, if it's 10 years old, what does the model think it should be? So I'm going to use my linear model from my calculator and do F1 of 10, basically saying if it's 10 years old, how much would it be? All right, so if it's 10 years old, it's going to be looks like $4,695.49. So I'm going to write down 4695.49. 4695.49. Probably already forgot. Confirm. 4695.49. So I'm going to be calculating the residual. Joseph, go away. Calculating the residual of this Corolla. All right, so that would be definitely negative. So 3,500 minus that. 3,500 minus this. All right, so we get negative 11, so $1,195.49. 1195.49. 1195.49. 1195.49. Sure, looks good. Make sure it's negative. All right. So there is the residual. Because if you see, the model says for a 10-year-old car, they're expecting you to pay just under $4,700. So this Corolla being listed at $3,500, right? That would be an actual deal because the model is saying you should actually expect to pay almost $1,200 more than that. So maybe something to look at, or you should look at, is the car in good condition? What's the mileage of the car? The other factors might be coming into why they're pricing it so much lower. Okay, now the last one, letter L. Would this regression model be useful in establishing a fair price for a 20-year-old car? So we can absolutely type in F1 of 20 and just see what it says. So this is a 20-year-old Corolla. That is old. But when I do that, a couple of things just are like going off in my head here. It says, when you type in 20, you should price it at negative $4,894.97. So basically, they're going to give you the 20-year-old car, and they're going to pay you just under $5,000. Well, that is just silly. That's never going to happen. So basically, go away, you're making me distracted. That was Leslie and Chloe. So basically, what I'm saying here is that doesn't make any sense. They're not going to give you the car and give you money. And another thing, if you just look at all of the data values, take a look at your range of your ages here. It goes from 1, so a year old, to 13 years old. If you want to find a predicted value for a number that's outside of the actual data, so we go from 1 to 13, 20 is way past it, that is something that you want to avoid because that is called extrapolation. All right, I'm not saying you can't do it, but I would highly recommend not doing it because you're going to get yourself into trouble by using a model that doesn't fit in terms of your range of input values. All right, so again, we're already cautious when we use models because we know they're wrong, all right, but we need to be even more cautious if you're using extrapolation, and basically what I tell students is you don't want to do it, okay? All right, looks like we've answered everything. Hopefully, I know I went out of order. Hopefully you guys have a good sense of what we're doing here. And I'm going to end this example.